started. Uh, in this semester, we keep working on the stereo matching and semantic segmentation tasks with the convolutional neural network. Let's have a review on our last semester. We proved our idea on the FlowNet on the stereo matching network called FlowNet, and we got the 80% improvement on the segmentation with the disparity. So in this semester, we want to prove our idea on a segmentation task network like the ResNet. Here are the structure of the ResNet. The input is the left and the right image pairs, and the output is the left-right segmentation and the disparity map. We use the warp method to make the connection with the segmentation and the stereo matching text together.
Here is the details about the warp method. There are 3 reasons we use warp. The first is that there is no segmentation ground truth for the right image in the dataset. And the second is that we want to make full use of the original segmentation network, including the network structure and the patron weights. And the third is that as a feature learning task, the right image features may provide further confidence on the fused result. And about the principle of the warp, it's quite simple. It's only the linear warp because for stereo matching, there's one assumption is that the pixel on the left image and the right image should at the same horizontal level. And here is a simple here is an illustration image of the warp method. So next, let me talk about our experiment details. In the training phase, we first implement the warp layer in Caffe, which is modified from 2D warp into 1D warp, and then follow the previous structure, and we do training. And during the training, we try different settings like different loss weights and learning rate. And finally, we could not get any improvement. The right table shows part of the data of our experiment. So in order to find the upper bound of the warp method, we next do the experiments in the testing phase, and we use MATLAB to evaluate the performance, and we run the original PSP.NET or ResNet, which means that we input the left image and get left output, and input right image and get right output. And after having these 2 outputs, we warp and fuse the images, fuse the outputs together. And in this experiment, we still could not gain any improvement. So we try to analyze what's wrong with the warp method.
So we visualize the output of the fused segmentation, and from the image you can see that there exists two problems. The first is on the left side of the right segmentation output, because of the difference between the left camera and the right camera. On the right camera, maybe exists some noise on the left side of the image. And the second problem is in the cityscapes, there are many objects, and there may be some occlusion problems especially on the border of the object, which means there exists some hidden points on the border of the different objects, and we cannot use the warp method as these borders.
So in order to solve these 2 problems, we first mask the first 6 columns of the right output which are mainly the noise. And second, we use dilation to expand the ignore points. And here is a set of simple illustration. And the left image is the original mask, a mask for the ignore points on the depth map, and the right image is the mask with our solution. But however, with this kind of mask to work, we still cannot get improvement. So we think there may be some possible reasons for the failure.
And the first reason is there may be exists the confliction on the object border. We want to get the improvement on the segmentation from the right image features, and especially on the borders, where because of the occlusion problem we have mentioned before, we have to use the dilation method to ignore these points on these borders.
And the second possible reason is the inaccuracy of the depth map. Since the ground truth step is also generated by a certain kind of algorithm, so we try other depth map generators like CPM, SVS, and CRL. And however, those depth generator are not robust enough. So in all, we cannot get solid improvement again. So in all, we find that the warp method did not performs not well in this experiment. We think we think the warp method is not good, but there may be some other tricks to combine these two tasks together smartly. So we should learn more from the recent papers on multitask learning, especially those related to our topic.
And we also review the some recent works on the multitask. One paper considered these two tasks as a transfer learning, and their conclusion is the segmentation task and the disparate stereo matching task are not quite connected. You can see the conclusion from the image that is from the text similarity tree from the image, and which means these two tasks is not reasonable to make them connected. That's all for our video.
Mm.